Math in web development. Well, basically, this is the topic I'm going to touch on today. And we're going to see that maths are everywhere, particularly because we're working in a programming language, but also because the most direct application is going to be here in this concept called recursion. So the first thing we have to do is ask ourselves, what is recursion? Most of us already know the concept, but I'm still going to mention it. And we can see this definition. This definition can be a little bit fun, but it's incorrect, actually. Later, I am going to explain to you why, but it is basically that recursivity cannot be infinite. It has to end at some point. And in this case, well, this doesn't happen because it repeats infinitely. So what we can call recursion is functions that call themselves. But how does recursion work? What are the fundamentals of recursion, the basis of recursion? We're going to see that recursion is a direct application of mathematical induction. So what is mathematical induction? It is a mathematical method that is used to prove whether a property is true or false for integers. Integer is what we know, for example, 0 and 1, and move forward, 2, 3, 4, 5. So to do this mathematical induction, we have two steps. First, the base case. And in the problems, we're going to find that it is an equivalence, for example, 1 or 0. And the inductive step, which is where we're going to prove something, or we're going to do something with all other, for example, what's going on that is happening, what's different from 1 or 0, or what we're using as a base case. So we're going to see an application of mathematical induction in the hello world of recursion. So we have this hello world, which is a function that solves the factorial of a number. So what is a factorial? It is the multiplication between one given number and all its previous numbers up until 1. So to apply this induction, we have the base case, which is n equals 1. And in that case, when n equals 1, it's going to return 1. But in all other cases, as long as the number is not 1, the function is going to multiply that number with the previous number. So for example, if n equals 5, that is going to check that is different from 1, and then it's going to multiply 5 by 4, and at that time it's going to call the function again, and that 4 number that we have is going to go through the function again, and successively that is going to end up in the base case, that is number 1. So here is another example. It's going to be a little bit more complex, where we have a string. And with that string, we're going to find the combinations that we can make with its character. So as we can see, we have an if that string equals an empty string, that is, for example, the first step, the first induction step, in which we have a base case. And if it's not empty, then it's going to continue applying, and it's going to continue calling itself and following these parameters that we are giving to the function. So here we are giving the first case, for example, an empty string, or just an empty space, and then a string with characters. So we're going to see that we are going to obtain all these characters that are here below in a comment when we apply this inductive definition. So how we can see here that we have plenty of methods. For example, substring and charAt. The one uses ordered pairs, and the other uses like subsets. So these are all mathematical concepts. And just as a little review of recursion, it is usually mentioned in this type of topics that the advantages that it has using recursion. So we can see that mainly it is about recursion uses a lot of resources such as time execution and memory spaces. So those are the first disadvantages, but recursion also has one advantage, that is, for example, that it is a pure function in the sense that it does not alter any other part of the program, but we can just say that it is a relationship between the parameters and the return values. So this is very convenient when we're working the paradigm of functional programming, because that is exactly what we need, that our values are not mutable. And this does happen in iteration. And as part of this review, I would like to mention as well in which cases recursion is more convenient to use. And it is mainly in problems that are naturally recursive. We can see that we have here an array. This array has nested arrays. So we see that recursion is present because we have to, well, what we want to do and what we want to obtain here is a flat array. So these nested arrays can be flattened, and this would be an example of recursion. Another case in which we can use recursion is when the data is naturally recursive. In this case, we have paths. We can see that when we have a folder within a folder, in that case, recursion is very, very efficient. After this review, what we can see is that programming languages such as JavaScript are based in logic and mathematics. And the question really that we need to ask ourselves is, do we need to know math to program? And the answer is obvious for some, for many that work in web development, and that is, well, not necessarily, but knowing the fundamentals of how these methods work or what we use works day to day as programmers can lead us to solve problems that look difficult and solve them in a very simple way. We can see this, for example, when we have problems that maybe we just get them out of the internet or we just develop them ourselves, and they lead us to a long code to just get to the solution. But sometimes these solutions just lead us to errors or problems that we can't solve in any other way. So the problem that I showed previously, in which we wanted to flatten an array, can be solved with a flat method. But many times we do not know, we really do not have in our memory all our methods. So it is not enough with Googling and finding a solution, but what we really need to do is knowing what we're doing or what are we trying to achieve and how are we going to do it to get to a solution. And with that, I'm not saying that study a career in maths or engineering. Just simply, if you want, to go deep in these subjects, you will be able to achieve better solutions, and they're going to be useful to you in all aspects of web development. So thank you very much. For all who are curious and who want to know more about this and want to solve functions, solve problems, and want to understand this topic about recursion, I would leave you some links here, and I will leave you a series of videos which is about maths for programmers, which uses ordered pairs to solve problems, and other concepts such as sets that can be very useful. So I hope you have liked this, and thank you very much.